welcome to the session 10. So in this session we are going to discuss upon the super keyword, which is a new keyword in your Java program, and the inheritance, how we are going to use the inheritance at the multi-level hierarchy, as well as the method overriding in inheritance. Right. So now when I'm going to talk about a super keyword, which is a new keyword in your Java program, just look at this program example, which we have already discussed about this program example in the previous session. Just look at this program now. I'm just going to have a class box, which is going to be a super class, and I'm going to have a subclass, which is going to extend or which inherits from the class box. Just observe there are 3 data members for the super class and 1 data member for the subclass, what I have been defined. And the constructor of the superclass is going to initialize all its 3 data members. Now, once I'm going to be in the subclass member, so now I need to again initialize the width, height, and the depth along with the 3 data members of the superclass as well as the data member of its own class. I need to do this because whenever we are going to create the object for the subclass, remember this, when I create the object for the subclass, the object for the superclass is not created. It's not going to create. So that means there's only one object what I'm going to create for the subclass. Upon creation of the object for the subclass, the constructor of the subclass will be called. And there is no any parameter what I am passing out for the superclass, hence the default constructor of the superclass will be called. If you are not calling the constructor, upon the creation of an subclass object, in that case the default constructor of the superclass is called. Remember this. Hence, so now this is a parameterized constructor which will be not called right now if I try to create an object. Fine. So now there can be a scenario. Now there is going to be a scenario somehow when I create an object for the subclass. Now I need to make sure that instead of calling the default 0 parameter constructor of the superclass, I want to call this specific parameterized constructor. I need to do this. And so now whenever I want to look into this, hence just look at these 2 codes now. Fine. Hence now as well as what I'm saying is that the constructor should be called. So even if you look at the code, so this code is replicating. I am initializing in the superclass as well as I am initializing in the subclass. I will just show you how exactly I can eliminate this using the super keyword, and that is what we say, call to the superclass constructor using the constructor of the derived class or the subclass. When the constructor of the subclass is called upon the creation of an object, now we are going to make sure that the call for the superclass constructor can also be made, and this is possible using a super keyword. This is the one advantage or the one usage of the super keyword. Hence, now we will see how exactly this is done, but look into the second scenario where the second usage of super will be coming to picture. This is the first scenario where I need to call an superclass constructor whenever the subclass constructor is going to be called. The first scenario and the first usage of the super keyword. The second scenario is that now just imagine the data member is going to be private. By default, all data members are private. Instead of stressing out that, let me stress out only on this point that right now the float width is a private data member, and you are aware that whenever we are going to have any private data member, if it is access specifier, then even the derived class or even the subclass cannot use the private data member in its class. Fine, that is what we discuss about private, public, and protected. And so now if this is a private data member, so your subclass cannot access. That is what the second scenario is. But right now I might be in a scenario or a situation where even though the data members are private, somewhere I should be, being a derived class or being a subclass, I should be able to access the private data member also. Hence, the second usage of the super keyword is access to the superclass private members. Whenever you hear the word super, the super keyword, remember these two scenarios and remember these two usage of the superclass. Now we will see exactly how we are going to use the super keyword to call the constructor of a superclass and how we are going to use the super keyword to access the private data member or the private members of a superclass. So now whenever we are going to make a call, now just look at this, the same program what I have just put over here. Just look at the modified program now. Fine. So now if you just look at the program, is similar. The only thing is whatever the code we add, width equals the redundant code, I was putting the same job again. The redundant code has been replaced with one statement called as super. The super is the keyword and I need to pass the argument or the parameter list. That is, now the super constructor takes 3 parameters, hence you need to make sure you're going to pass 3 parameters only. If you don't pass any parameter, in case if you're using super keyword with 0 arguments or 0 parameters, then the default constructor of the superclass will be called, which doesn't initializes anything. But right now, if you pass anything less than 3 or more than 3 parameters, it's going to be parameter mismatch and you're going to end with a syntax error. Hence, make sure you're going to pass the actual number of parameter what your superclass constructor is going to take. That is what we put it over here. The super keyword is used with the argument list. This argument list should match with the superclass constructor. So now the redundant code has been removed. The first thing is done. The second thing, whenever I'm going to create an object, for this class, the derived class or the subclass, the constructor of this class is called as box.w is called. By passing 4 parameters, I'm creating the object and calls the constructor. And if you just observe, whatever the super keyword have been replaced inside the constructor of an derived or the subclass, it is going to be the first statement, and this should be used only inside the constructor of the subclass. You cannot use this as a usual function call which we are going to put anywhere in the class. You're not supposed to do that. It should be, first point, it should be placed inside the constructor of the subclass only. Second important restriction, this should be the first statement of the subclass constructor. I cannot use weight equals m, then I cannot use super w comma h comma d. It should be the first statement. It should be inside the constructor as well as it should be the first statement in your derived class or in your subclass. That's fine. So this is what and this is how it's going to work now. So when I create an object for your box.w class, which is a subclass, in this case we are going to call the constructor of the subclass, that is box.w. So now when the control comes here, this keyword, this will call the superclass constructor. The superclass constructor is called, we initialize with the value of w, the value of h, the value of d to the 3 data members. After execution of this, the constructor of the subclass is executed. And even observe on the order of the constructor execution. So though the constructor of the subclass is called first, but the execution of the superclass is executed first, because the very first statement of your subclass constructor is the superclass constructor. Hence, even though if I am creating the object for the subclass, the first constructor to be executed is the superclass, then the constructor of the subclass is executed. Even make a note on the order of the constructor call. Fine. And so now with this, just look at one more example how this is going to be used. So now I'm just going to have the same program using super keyword wh, and I'm going to have one more class now. Just observe here. I'm just going to put one more point here. Remember, one more point with this example is going to show you. Fine. I'm going to have one more class here, box C, which extends box W. So now this was subclass for the box. Now this becomes superclass for the box C. Fine. And now I'm going to have a super keyword which is going to call the constructor. Now which constructor this is going to call? Yes, this keyword super will call the immediate constructor of its superclass. Now box C will not call the constructor of the box because this is not the immediate superclass. This is an indirect superclass but not the immediate superclass. Hence, when I use super keyword to call any constructor, remember this point, it's going to call the immediate superclass constructor only. And so now my immediate superclass constructor, which is of the box W, takes 4 parameters, and so I am passing 4 parameters here. Fine. And it's going to have its own data member and it's going to put the value. Along with the 4 parameter, it's going to accept one more parameter. And so now this class, when I execute the constructor, is going to call its superclass constructor, and once this constructor is called, this is going to call its superclass constructor, and upon execution of this, we are going to complete the execution of this constructor. Upon the execution of this, the execution of this constructor will be called. Again, make a note on the order of the constructor call. And so now when I create an object for the box W, I'm going to call the constructor with 4 parameters because I want only the width, height, depth, and the mass or the weight. Fine, I just need only 4 values, and so I'm passing 4 values. Out of those 4 values, 3 I'm passing as a parameter for the superclass constructor, and 1 parameter I'm going to use for this class data member initialization. So similarly, when I'm creating the object for the box C, I'm going to pass 5 parameters. I'm going to pass 3, 5, 7, 2, 1. I'm going to pass the 5 parameters. 1 parameter will be used by its own constructor. Remaining 4 will be passed as a parameter for this. So this is how the super keyword is going to work as the call for the constructors. Fine. And now just look at this one more example. So until this point of time, whenever I was telling, so I need to pass parameters. Now for example, if this constructor takes 3 parameters, if I need 1 more parameter, I should take 4 parameters. This is not a strict rule. So nowhere the list of parameter will never depend upon the constructors. It's you how you decide. It is need not that every time I need to accept the 4 parameters or the number of parameter what the constructor takes plus 1. It depends upon how many data members you have. It depends upon how you want to initialize, or it depends upon what value you want to initialize. If you want to initialize all these data members through constructor with the value what the user is going to give, that point of time think about this structure whatever I have been explained. If that's not the case, if you are free enough to give any value, you can even do in this way also. That is, here I am going to use 4 parameters. Observe here, I'm using only 1 parameter here, and the remaining 3 values I'm giving it as a constant. Somehow in any other way, either you pass it as a parameter while I'm creating your object, or you're going to give the value for the constructor. Irrespective of that, when you use the super, make sure it has got 3 parameters because the constructor has been defined such a way. This is how you're going to make the super keyword again. So remember this, there is not the hardcore that every time the parameter should be increased by 1 whenever I'm going to make use of super keyword. You are free enough, but the number of parameter and the type should always match. Fine. So with this, just look at one more example what I want to put it over here. So now all these examples what I've just shown you, it was just where we're going to pass the parameter of the any of a basic type or the primitive type. But just observe, I have a constructor now for the superclass which takes box as an object or its own object. And so now when I create an object, it has got 3 data members, and using that member I'm initializing, height I'm initializing, depth I'm initializing. Fine. So this you need to understand how we pass a structure object or how do we pass a class object as a parameter for another function or any member function or the constructor. The same thing what we are going to do here. Fine. So now I'm going to have subclass now. I'm going to create an data member as usual, and now I'm going to have a constructor which takes an object of its own class. Hence I'm going to have object here. That is, now BW is the object type, box W, and I'm using super keyword, and I'm using the object of the box or the subclass and the weight of the same member. Now this should work fine. Everything works fine. But what important thing you should note here, or what you may have surprised here, is just look at this. In the previous example when I was discussing, I told you that the constructor value whatever you're going to pass, the number of values should be matching with the constructor and the type also should match with the constructor. So now observe here, really the type is matching and the number is matching. I need one parameter for the constructor, there is one parameter. Second criteria, whether type is matching, carefully observe here. Now this is going to accept an object of the type box, and I am passing an object of the type box W. So you are saying this is going to be a type mismatch? Yes, at the outlook it is type mismatch. But if you remember in the previous session, I have just told you that an superclass object can refer to the object of an subclass. Fine. A superclass object can hold the reference to the memory address or the object memory of a subclass. That is where this will come into picture. I am creating a reference of a superclass and I am assigning the memory of a subclass. Now this should work fine. So when I pass this object over here, now B will be aware of only its own data member, though the subclass object has got 4 data members including 3 plus 1. But remember, the reference object of superclass will be able to access only the 3 data member of its own. The 4th member, which is weight, cannot be accessed because it is focus area is only on its own data member. This is what we call this as clone of an object. Use the same object to initialize its own same of data members. Right? So with this, we are just going to summarize how the super keyword should be used whenever we are going to call the superclass constructor. Hence, just to put it in the words, so superclass object is not created when the subclass object is created. Hence, only the subclass object is created. Upon the creation of this, the constructor is called for a subclass, which in turn will call the constructor of a superclass. If you don't use the super keyword, only the default constructor of your superclass will be called. If you want to call the defined constructor, you need to use super keyword. Hence, the subclass object creation will call only the subclass constructor with the parameters. So to call the superclass constructor, we use super, the keyword, and the argument list. Super argument list should be always inside the constructor of a subclass. As I mentioned, in subclass constructor, if you are using a super argument list, make sure it is going to be the first statement of the constructor. A subclass can only call its immediate superclass constructor. So though you are going to inherit from another superclass at the highest level, you cannot call the superclass constructor. You can call only the immediate superclass constructor. A subclass constructor is responsible for passing values for the superclass constructor. There is no any other way. You don't have any other way to pass the parameter for the superclass through the subclass object. This is the only way of using super keyword. So this is how we are going to use the super keyword for the first scenario whenever I want to call the superclass constructor. Now we'll just look at the second scenario where I should be able to access, being a subclass, I should be able to access even the private data member by default, which is not possible. But right now I am in a situation where I need to have that. Hence, if you want to do so, I can make use of super keyword. So which similarly acts as this operator. If you remember this operator or this keyword, so I am going to use this keyword to refer the current object's data members, or to refer the calling object data members, something like this dot width, this dot height, so on. It is similar to that, but I use the super keyword here. Now just look at this program example now. Now this program, if it's per data member, right now it's an illegal operation for me because I cannot access the private data member. But if you want to access, so still the width is private data member. If I want to still access this in the subclass, use the super keyword dot operator and the private data member. Now this is going to work fine. So second use, how we are going to use the super keyword when I want to access. So this concept is so simple. You can easily understand how this is going to work and what's the use of that. Fine. So next thing is, with this super keywords usage, now just look at this, the type of inheritance. So until now I have just given you some examples how the inheritance is going to work and how we are going to implement the inheritance, but nowhere I specifically mentioned the types. I think this is the right time to mention that. And so now I'm going to have single inheritance, or we can call this a simple inheritance, where I'm going to have only two classes which will be part of inheritance. That is, class B will inherit from the class A, and so I've got only one subclass and one superclass. Whereas I can extend this and I can go at the multi-level inheritance. This is level 1 and this is level 2. And so I'm going to 2 levels of inheritance. If you want, you can go further. I can go for the level 3. I can go for the level 4 and so on. Hence in these 2 levels, I'm going to have 2 subclasses and 2 superclasses. That is, if I keep class C as a reference, I'm going to have class B is going to be the superclass, and for the class B, I'm going to have class A as the superclass. If I'm going to call this as class B, this is going to be subclass of class A, and this is the subclass of class B. Hence, I'm going to have multiple superclasses and multiple subclasses. And I can have 2 different separate classes which can refer the same class as a superclass. Hence, we call this as multi-single path. We can even have this as multi-single path. And now the multiple path. Just observe here. I'm going to have class C. Now class C has got 2 superclasses. It has been inheriting by 2 different classes and 2 separate classes. Now this is not possible in your Java program. You are not supposed to have a multiple inheritance in your Java program. This is not going to allow you. That means a single class cannot have or cannot derive the properties from more than one class. Fine, but one class can share its properties to more than one class, but one class cannot derive properties from multiple classes. Hence, any single class, you should have only one superclass. The class B has one superclass, class A. Class C has one superclass, class A. Hence, this is fine, but this is not fine. Hence, this is not an legal type of inheritance in your Java program because it doesn't support this. But C++ program will support this. Hence, in Java, it's not going to support. And I can just create the inheritance mixing all this. It is, I can have multi-single path, I can have a single inheritance, I can have multi-level inheritance. So in call this hybrid inheritance. So different types. Hence all these types is going to work as usual, but there's specifically one type of inheritance which I should discuss with some example. And so let me concentrate on the multi-level hierarchy inheritance or multi-level inheritance. And the reason what I want to discuss in this multi-level inheritance is the order of constructor call, which I've already mentioned. And so just look at this program. In this program, if you just look at this, I'm going to have class A and its constructor, which I'm going to have I am A, and the constructor of the class B, which extends A, and I am B, and C extends B, I am C. Hence, I'm going to have a main function and I'm creating the object for C. Remember, when I create the object for the class C, the constructor of the C is called. Before the constructor of C is executed, if I don't use super keyword also, the constructor of its superclass will be called and the default constructor will be called. Fine. And the default constructor is going to be a 0 argument. And so now before C is executed, before this constructor is executed, B constructor will be executed. Before the execution of this, the execution of A will be called. And remember, even if I don't use super keyword, this is how the constructor is called. Hence, you are going to use the super keyword when you want to pass the parameter or when you want to call the parameter as constructor of your superclass. That is where the real usage of super is going to be. Hence, for this reason, when I execute this program, I will get this as the first statement, then I am B as second output, then I am C as the output 3, and this is the constructor order of calling. The order of the constructor will be called in the order of the derivation, the order how you have derived from A to B, B to C. Hence, in the same order, the constructor will be called. Hence, if you are going to have a program with the super keyword or not, it's both or same. And so now I've just modified the same program. Now I'm going to have 0 parameter, I'm going to have 1 parameter constructor. So where I'm printing it as I am 0A0, I am parameterized or parameter para A, printing the value what I'm going to pass as a parameter. Similarly with the class B, where I'm going to have B plus 1 is the parameter what I am passing using the super keyword to call the parameter as constructor. And here, even though if I don't use this, still this is same. This will call 0 parameter as constructor. Even the C, it is similar to the class B. Fine. So now when I create the object for the class C as object 1, know what happens. Just see, this is going to call the 0 parameterized constructor. Hence, we'll see what output we are going to get. This is going to call the 0 parameterized constructor, that is C 0 parameterized, and this is going to call super with 0 parameter. Hence, even if you don't mention here, this would have been called the 0 parameterized its superclass constructor only. Hence, there is no any difference of using super keyword or not super keyword in this case, in this scenario. And this is constructor is called, again I'm going to call the 0 argument constructor. Hence, now there is no any further hierarchy to go behind this. Hence, the constructor call will stuck at this point and it will start printing. I am 0A and I'm going to get this as output. And the next constructor is the B, which was supposed to execute. Next, constructor C, which was supposed to be execution. So now if I am going to create an object with a parameter, this is going to call the parameterized constructor. Now you need to specifically use super. If you don't use super here, this constructor call would have been called the default constructor with 0 argument. But now I am using a parameter. Now this is where this constructor is called. This is the difference of using super keyword with the parameter and without parameter. And so now this is going to call the constructor B with the parameter, replacing C plus 1 with B. The value of C was 1. 1 plus 1 is 2. b is replaced with 2, and now this is going to call the parameterized constructor of its superclass, that is a, and now a is replaced with 2 plus 1, that is 3. Hence, so now there is no further to go. Hence, is going to print the statement as I am para a with the value 3. Fine, and this constructor is completed its execution with I am para b. So this should be para b. I just made a mistake here, so make a correction here. So I'm just going to have 2 over here, and again the same problem here. So this should be I am para c. I'm going to have I am para c, and I'm just going to print the value of c as 1. This is how the order of the constructor is called, and even just observe how exactly the super keyword is used. The super keyword's efficiency and its real usage will come only when you pass with the parameter. Fine. And this is how we are going to have the super keyword with multi-level hierarchy also. So apart from this, when I talk about inheritance, there's one more important topic what I want to put into discussion. That is the method overriding. So you might have heard about method overloading, function overloading. Similar to that, we are going to have method overriding. Just observe here. I'm just going to give you in short how and what this method overriding is. I'm going to have a super class and I'm going to have a subclass. If you carefully observe, I'm going to have a member function in the superclass with the name show. Let that body be anything. So don't look at the body. Body can be anything. Just look at the function declaration, the function definition, the function header. The function name is show with 0 parameter, and even I am declaring one more function or adding up one more function in the class B with the same name, same parameter, and so now you can say signatures are totally same. Remember this, the signature is totally same. When the signature is totally same, this is not an illegal operation in your Java program. You can do this. Now, if I have done this, just look at what happens to my program execution. So I'm creating the object for the class B and I'm going to call .show. Now observe, now think. This class is inherited by class A. That means how many member function it has got? It has got 2 member functions. One member function what it has defined as its own function, and one more function of your super class. So now when I execute this, I am going to get the output as, it can be I am show of A or I am show of B, but you're going to get the output as I am show of B only, because whatever the function call is going to happen, the compiler will try to search in the local structure. If it finds the call in the local structure, like show is found in the local body itself, then that function is called. If it's not able to find in the local body, then it will look at the derived body. Now it is found, hence you're going to get the output as I am show of B. That's fine. So now, hence if you want to call even the show of the function, so then you should think about different alternate, but right now just observe this function has been called over this function. That is, the subclass function has been called over the member function of the superclass. This is what we call overriding. The function of the subclass will always override the function of a superclass if the signatures are same. If the function name, the parameter list, the return type, the parameter type, if everything is identical, in that case, the subclass member function will always overrides the superclass functions. This is what the function or the method overriding is going to be all about. So now just look at one more example. Now, so though the function overriding is existing, somehow I need to call the superclass function also. That means the override exists, but somehow I need to call the superclass function also. If it wants to happen, you can make use of super keyword. So in the show function, I'm using super.show. Now when I execute this, now this is going to call the show function of the superclass first, and then the function of the subclass will be executed. Hence I am somehow removing this overriding. So the function of the class B was overriding the function of class A. Now using super, I'll reverse this. So this is what you should do with method overriding, and you making usage of the super keyword again by using the method overriding concept to override again, overriding it. Fine, this is how the super is going to work. But one more point what I want to stress out it, now don't get confused between overriding and overloading. Just observe these two case scenarios. Fine, so now I'm going to have show and show function. What I discussed, everything is identical. When everything is identical and when this is inheritance, then we call this as method overriding. Fine, and I'm going to get the output as I am show of B if I call dot show function. The same thing observe over here. Fine, so now I'm going to have show function here. The name is only same, but the parameter has been changed. That means there's a different signature. The signature is not identical. So in this case, you cannot call this as function overriding or method overriding. This should be called as function overloading or method overloading. So when the same statement is executed, now this is going to call the show function because the syntax of what I'm calling the function will match exactly with the class A function. Hence I'm going to get the output as I am show of A. Fine. Now this is how the function overriding or method overriding and method overriding is going to behave. Now this is what you need to understand in this session, and thank you for this session.